Welcome to Math Defined. Today we're diving into dividing integers. We've covered adding, subtracting, and multiplying integers in previous videos, and now it's time to tackle division. Before we jump into some examples, let's start with the basic rules for dividing integers. Just like with multiplication, the sign of your answer or quotient depends on the signs of the numbers you're dividing. If both integers have the same sign, the quotient will always be positive. If the integers have different signs, the quotient will always be negative. Let's jump into some examples to see these rules in action. Our first example is 14 divided by 2. Both of these numbers are positive, so we're dividing two integers with the same sign. That means the quotient will be positive. And what's 14 divided by 2? That's right, it's 7. So 14 divided by 2 equals positive 7. Next, let's divide negative 18 by negative 3. Here we have two negative integers. What's the rule? If the signs are the same, the quotient is positive. So negative 18 divided by negative 3 equals positive 6. Now what happens if we divide 24 by negative 6? Notice that these integers have different signs. One's positive and the other's negative. This means the quotient will be negative. And 24 divided by 6 is 4, so 24 divided by negative 6 equals negative 4. Now what about negative 15 divided by 3? This time, the negative integer is being divided by a positive integer. Does the rule still apply? Yes, the signs are different, so our quotient will be negative. And 15 divided by 3 is 5, so negative 15 divided by 3 equals negative 5. All right, now that we've reviewed the rules and did a little practice dividing integers, let's dive into a couple more complex examples that will put these rules into practice. First up, we have the expression negative 8 minus 14 divided by 2 plus 5. Remember, we need to follow the order of operations. We'll tackle the division first and then handle the rest step by step. Let's see what happens. So negative 14 divided by 2 is negative 7. We bring down the rest of the expression, and now we have only subtraction and addition left. Starting at the left, we have negative 8 minus 7, which we have learned in previous videos is the same as negative 8 plus negative 7, and that equals negative 15. And the last step is to add negative 15 and 5, which equals negative 10. So the answer to our first expression is negative 10. Now let's switch gears and look at an expression that involves variables. In this second example, we have this expression written in the form of a fraction with variables. The variable x multiplied to z divided by negative y, where x equals 10, y equals negative 2, and z equals negative 5. After substituting our values in place of the variables, we'll multiply and divide to get the result. Let's break it down together. We'll begin in the numerator by substituting x and z with 10 times negative 5. Then looking at the denominator, we need to be careful because the variable is negative y, and the given value of y is also a negative value, negative 2. Next, we'll simplify the numerator. 10 times negative 5 equals negative 50. And then in the denominator, the two negatives simplify to positive 2. The last step is to simplify the fraction by dividing negative 50 by 2, resulting in negative 25. And there you have it. The solution to our second expression is negative 25. Let's do a quick recap. When dividing integers, remember these key rules. Same signs give a positive quotient, and different signs give a negative quotient. Thanks for joining me today. Don't forget to like, give a super thanks, subscribe, leave a comment, share it, and hit that bell to stay updated with all things math. Until next time, keep math awesome, and I'll see you in the next video.